Welcome back to my YouTube channel GrandpaMathematics. Last video we have seen how to evaluate the definite integral by substitution method. Today let us see some important properties of definite integral, and we shall see the proof of all these properties one by one, and then we will evaluate the integral by using the properties of definite integrals. We know for the definite integral a to b f of x dx is nothing but f of x a to b is nothing but f of b minus f of a, where f of x is the antiderivative of f of x. That means if we integrate f of x with respect to x and if we get capital F of x, then the value of this integral will be f of b minus f of a. Now the first property of definite integral is integral a to b f of x dx. So this is equal to integral a to b f of y dy. So again we'll take let capital F of x be the antiderivative of small f of x when we integrate this with respect to x. Therefore, integral a to b f of x dx. So this is nothing but capital F of x a to b is nothing but, first for x we have to substitute the upper limit f of b minus f of a. Now integral a to b f of y dy, the same way f of y a to b, when you substitute the upper limit f of b minus f of e. From 1 and 2, you can see that integral a to b f of x dx is equal to integral a to b f of y dy. Or we can also derive this. Let I is equal to integral a to b f of x dx. We call this as 1. Let x is equal to y. We are taking x is equal to y. This gives what? Dx is equal to dy. When x is a, y is also is equal to a only, y is also b only, is equal to integral x varies from a to b, y also varies from a to b, f of, we have taken x is y, f of y dx nothing but dy. Therefore, integral a to b f of x dx is equal to integral a to b f of y dy. Now, second property, integral a to b f of x dx, this is equal to minus integral b to a f of x dx. Now what is integral a to b f of x dx? This is nothing but f of b minus f of a. We call this equation 2. Then what is integral b to a f of x dx? Integral b to a f of x dx. So this is equal to f of upper limit a minus f of lower limit b. So we can take a minus sign outside. We can write this as f of b minus f of a What is f of b minus f of a? That is nothing but integral a to b f of x dx. So minus integral a to b f of x dx. So integral a to b f of x dx. Now integral a to b f of x dx is multiply both sides by minus sign. We'll be getting the first one. If you multiply this by minus 1, integral a to b f of x dx is there. If you multiply this by minus 1, minus integral b to f of x dx is there. Hence, we have proved it. Third one, integral a to b f of x dx. This is equal to integral a to c f of x dx plus integral c to b f of x dx. So we can write this integral a to b f of x dx. We can write integral a to c f of x dx plus integral c to b f of x dx like that. Now, what is integral a to b f of x dx? Integral a to b f of x dx. This is nothing but f of b minus f of a. And what is integral a to c f of x dx? This is f of c minus f of a. Integral c to b f of x dx is f of b minus f of c. Now we'll add 3 and 4. We'll add these two equations. 4 gives integral a to c f of x dx plus integral c to b f of x dx. So this is equal to f of c minus f of a plus f of b minus f of c. So these two gets cancelled. We are left with f of b minus f of a. F of b minus f of a is nothing but integral a to b f of x dx. That means given the definite integral a to b f of x dx, we can write this as a sum of two integrals where integral a to c f of x dx plus integral c to b f of x dx like that. Fourth property, integral a to b f of x dx. So this is equal to integral a to b f of a plus b minus x. A plus b minus x dx. Okay. So integral a to b f of x dx is equal to integral a to b f of a plus b minus x, a plus b minus x dx. Now let I is equal to integral a to b f of x dx. Now let x is equal to a plus b minus y. So x we are taking, let x is equal to a plus b minus y, and we get dx is equal to minus dy. Here x varies from a to b. When x is a, y is equal to b. When x is equal to b, y is equal to a comes from 2. I is equal to integral. The next property is replace a by 0 and b by a. What will be getting? Integral 0 to a f of x dx. So this is equal to 0 to a f of a minus x dx. In the we are replacing a by 0 and b by a. So integral 0 to a f of x dx is equal to 0 to a f of a is 0, b is a. So a minus x dx. The property is integral 0 to a f of x dx. This is equal to integral 0 to a f of a minus x dx. Integral 0 to a f of a minus x dx. So most of the problems will be using this property only to evaluate the integral. So let I is equal to integral 0 to a f of x dx. We'll replace x by a minus y. Let x is equal to a minus y. So this gives y is equal to a minus x, and dy is equal to minus dx. When x is 0, we are getting the value of y is a. When x is equal to a, when x is a, y becomes 0. Therefore 1 becomes I is equal to integral x varies from 0 to a, y varies from a to 0. So a to 0 f of x is nothing but a minus y, and dx is minus dy. We can take the minus sign outside. Minus integral a to 0 f of a minus y dy So this we can write as I is equal to integral 0 to a f of a minus y dy. Then using the first property, we can change the variable y to x. Integral 0 to a f of a minus x dx. So integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Next property is integral 0 to 2a. Integral 0 to 2a f of x dx. This is equal to integral 0 to a f of x dx plus again integral 0 to a f of 2a minus x dx. See here, integral 0 to 2a f of x dx, we are writing 0 to a f of x dx plus again 0 to a f of, in place of x, we are writing 2a minus x dx. Let us see how to prove this. Left hand side of the equation 1 is 0 to 2a f of x dx. This, by using the third property, we can write this as integral 0 to a f of x dx plus integral a to 2a to 2a f of x dx. We will say this equal to integral 0 to a f of x dx plus, because we already got this term, 0 to a f of x dx, already we got this term. This will take this as I suffix 1, say. We call this equation 2. Now what is integral 1? This is nothing but a to 2a f of x dx. We call this 3. Now let x is equal to 2a minus y. How I am putting 2a minus y? We want f 2a minus x we want. So I am replacing x by 2a minus y. Later on we will change the variable y to x. So we want 2a minus x. That's why I am putting x is 2a minus y. This dx is equal to minus dy and y is equal to 2a minus x. When x varies from a to here, then x is a, y becomes what? Use this. When x is a, y becomes 2a minus a is a only. When x is 2a, x is 2a, x is 2a means 2a minus 2a 0, y becomes 0. Therefore 3 becomes what? I suffix 1 is integral x varies from a to 2a and y varies from a to 0. So a to 0, then f of x we are taking as 2a minus y and dx is minus dy. So we can write this as minus, we can take outside, minus integral a to 0 f of 2a minus y dy now minus integral a to 0 f of 2a minus y dy we can write as integral 0 to a f of 2a minus y dy, like that. So 0 to a f of 2a minus y dy. Now we can change the variable y to x. So integral 0 to a f of 2a minus x dx. Therefore 2 becomes for I suffix 1 I am going to write this value, integral 0 to a f of 2a minus x dx. So this property is integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. In this, if f of 2a minus x this equal to f of x, if f of 2a minus x is equal to f of x, then for this term we will write f of x only, then integral 0 to 2a f of x dx becomes 0 to a f of x dx plus integral 0 to a f of x dx. That is, if f of 2a minus x is equal to f of x, we can write like this. So this will be 2 times integral 0 to a f of x dx. Or if f of 2a minus x is equal to minus f of x, okay, 2a minus x, f of 2a minus x is equal to minus f of x, then one becomes integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus 0 to a f of 2a minus x becomes minus f of x. So minus f of x dx. So minus we can take outside. Then this becomes 0. So in this property, if f of 2a minus x is equal to f of x, then integral 0 to 2a f of x dx becomes 2 times integral 0 to a f of x dx. If f of 2a minus x is equal to minus f of x, then integral 0 to 2a f of x dx becomes 0. Now let us see what is even function and what is odd function. Let f of x be a function if f of minus x is equal to f of x, then f of x is said to be even function. If f of minus x is equal to f of x, then we can say the function is even function. For example, take cos of minus x. This is equal to cos x only. So we can say cos x is even function. If f of minus x is equal to minus f of x, then f of x is said to be odd function. For example, if we take sine of minus x is equal to minus sine of x, so this is an odd function. So the functions need not necessarily to be odd function or even function. Some of the functions neither odd function nor even function. Take for example, f of x is x minus x plus x square. What is f of minus x? Minus x plus x square. Then this is not equal to f of x. If we take minus outside, x minus x square, this is not equal to minus f of x. Integral minus a to a f of x dx. So this is equal to 2 times 0 to a f of x dx if f of x is even function. This is equal to 0 if f of x is odd function. Now integral minus a to a f of x dx, we can write this as integral minus a to 0 f of x dx plus integral 0 to a f of x dx, like that. Say this equal to I suffix 1 plus integral 0 to a f of x dx. Now what is I suffix 1? Integral minus a to 0 f of x dx, we call this as 3. Now let x is minus y. In this, we are putting x is minus y. So what will happen now? Dx is equal to minus dy. When x is minus a, y is equal to x is minus a minus y is minus a, so y becomes a. When x is 0, y also becomes 0. Therefore 3 becomes I suffix 1 is x varies from minus a to 0, x varies from minus a to 0, y varies from a to 0. So y varies from a to 0, f of x we have taken as minus y, so f of minus y, and dx is minus dy, so minus dy. So this we can write as minus integral a to 0 f of minus y dy, or we can write as integral 0 to a f of minus y dy, or the 0 to a f of minus x dx. So I suffix 1 becomes integral 0 to a f of minus x dx. Now for I suffix 1, we can write that value integral 0 to a f of minus x dx like that. Therefore 2 becomes I suffix 1 is equal to 0 to a f of minus x dx plus integral 0 to a f of x dx. Now this is equal to integral 0 to a f of minus x plus f of x dx. So this is equal to 2 times 0 to a f of x dx, 2 times 0 to a f of x dx if f of x is even. Even means f of minus x is equal to f of x. That is f of minus x is equal to f of x. So that means integral minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f of x is even function. What will happen if f of x is odd function? If f of x is odd function, then f of minus x is minus f of x plus f of x dx. It will become 0 if f of x is odd function. So let us summarize all these properties. 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x, or 0 if f of 2a minus x is equal to minus f of x. Minus a to a f of x dx is equal to 2 times if f of x is even, so this is equal to 0 when f of x is odd. So we have to remember all these properties to evaluate the definite integral. Thank you for watching. Next video we'll see how to solve the definite integral by using properties of integrals. Thank you for watching.